Technetium is a rare, silver-gray transition metal that tarnishes slowly in moist air. It is radioactive and a superconductor at temperatures of 11 Kelvin and below. Technetium was discovered by Dmitry Mendeleev, a Russian chemist who created the periodic table. He noticed that between manganese and ruthenium there was an empty space in the group 7 transition elements. He initially called this new element Eka-manganese. In 1925, a group of scientists in Berlin, Germany, named Tak, Nodak, and Berg, found the element 43 described as Eka-manganese, along with rhenium, while analyzing columbite minerals and platinum ores. Their discovery of the two new elements was published as X-ray analysis. Element 43, Eka-manganese, was named Mesurium. Their research was disputed and conclusions supported the discovery of rhenium but not Mesurium. However, in later years, it has been established that the group of German scientists did discover element 43, which is now called technetium. The samples contained traces of uranium, which was found to decay into technetium-99. A study in 1999 at Los Alamos National Laboratory in New Mexico reproduced the same 1925 German experiment, which supported the claim that Tak, Nodak, and Berg's original research was correct. However, the credit for the discovery of technetium is usually given to the University of Palermo in Sicily, Italy. Research shows that technetium is not found on Earth naturally. It was the first element to be produced synthetically. Spectral lines of technetium were observed to be naturally occurring in red giant stars and uranium ores.
Technetium was found naturally occurring in small quantities in uranium ore. It is usually found as the isotope technetium-99 as a waste product from uranium nuclear fuel. The isotope is produced by neutron activation of molybdenum-98 to form a product with a half-life of about 66 hours. Molybdenum-99. This beta decays into technetium-99. This isotope is seen in the light of red giant stars. All 26 isotopes of technetium have been proven to be unstable, except for technetium-98, which has a half-life of 4.2 million years. Technetium has not been found naturally occurring on Earth. It is produced synthetically via nuclear reactors. Uranium atoms collide with neutrons to technetium. Technetium is then turned into ammonium perchenate, which is combined with hydrogen gas to produce a pure technetium metal.
Technetium has very limited uses in everyday life because of its radioactive nature. However, two common uses of the element are in the medical field and the industrial field. Firstly, technetium can be used as a radioactive tracer. After being injected into a patient, the gamma rays emitted from the element are then photographed using a gamma camera, allowing medical imaging to aid in therapy and diagnosis. Also found in ammonium pertechnate, technetium is also largely used in steel alloys as a corrosion inhibitor. Additionally, technetium is used in optoelectronic devices and nanoscale nuclear batteries. As previously mentioned, the impact of technetium has been very significant in the field of nuclear medicine. In fact, Dr. Ron Weiner of ANSTO's Radiopharmaceutical Research Institute stated in an interview that about 80% of nuclear medicine procedures in the world use this isotope, amounting to about 10 million procedures a year.